Well now, welcome. So we've done a lot with volume. We've done volumes of various kinds. And so what I want to do in this screencast is I want to address the issue of when it shows up on a quiz, when it shows up on a test, we're not going to be told which way we should find volume. And so we want to talk about in this screencast some of the clues to what we might want to do and how we might know to do that. So we'll pretend that there's some function f of x, and we'll pretend that there's some other function g of x. This is the interval from a to b. This is the interval from c to d. And we want to do some things with this region R, and we want to talk about how to know what to do and when to do it. So let's pretend that we want to, I should use a color there. Let's pretend we want to spin about the x-axis. If we spin about the x-axis, we get some solid by spinning around like so. How do we know if we use disks and washers or if we use cylindrical shells? Well, the kind of slice we usually try to make is a vertical slice because that's a dx integral. If we make a vertical slice, that vertical slice is perpendicular to the axis of rotation. When the slice is perpendicular to the axis of rotation, this results in disks or washers. So in our case, we're perpendicular to the axis of rotation, and there are two functions involved, so we are going to do washers. And we remember how washers go. Washers was pi times a big radius squared minus pi times a little radius squared dx. The big radius from the axis of rotation to the farther curve, the little radius from the axis of rotation to the nearer curve. Every horizontal axis of rotation, the x-axis, y equals d, y equals -4, all of those, a vertical slice leads to washers. The radii will change depending on whether the axis is here or the axis is here or the axis is here. The radii will change, but the basic process will not. Well, what if we go about the y-axis? If we go about the y-axis and we still want to do a vertical slice, when the slice is parallel to the axis of rotation, this is always cylindrical shells because we slice and then it goes around like so and you get a paper towel roll. So what's the volume with a paper towel roll? 2 pi times the radius times the height times the thickness. 2 pi times the radius times the height times the thickness. So the radius goes from the y-axis out to whatever this x value is. The height of the paper towel roll is the difference between F and G. And then the thickness of the paper towel roll is a teeny tiny change in X. If we slice vertically, and that vertical slice is parallel to the axis of rotation, cylindrical shells every time. Depending on where the axis is. If the axis is over here at x equals b, it changes the radius. If the axis is over here at some negative number, it changes the radius. So then the radius changes, but the height is basically the same. and we have a dx because the slice is vertical. We could work these out where we slice horizontally. If it were easy to find expressions for the inverses of f and g, we could slice horizontally and do dy integrals. That's not usually necessary, but we could if we needed to. What I want to make sure I drive home in these 6 minutes is that when we slice perpendicular to the axis of rotation, we get disks or washers. When we slice parallel to the axis of rotation, we get cylindrical shells. If that's your takeaway, you're in great shape. I'll illustrate with some examples in another screencast.